Hi, Professor Lee here. In this video, I'm going to show you the Bazel, some of the basic usage of a Bazel, and perhaps some basic commands of a Git. And just to help you out, the intention of this lab is to get your guys' environment set up so that you're ready to program in C++ productively, and also set some minimal standards that will be uniform for everyone, that makes the grading easier and also makes your future group project easier, so you can use the same set of tools. And now I'm in a Mac environment. So I have the Windows installed in Parallels. So I'm gonna open my Windows environment, because 80% of you are using Windows. Now I assume you're using the latest Windows 10. So that's what I'm gonna use to show you. Okay, so let me go to my GitHub account. And let me take a look at the instructions. Oh, should be a search box here. Let me switch account. Okay. All right, I'll just, well, I already got some of the basic things installed. For example, I have Visual Studio Code, and I installed the plugin. For that, you can take a look. Let's take a look at this. Installing Visual Studio Code should be fairly straightforward. Now, if you choose to use a different IDE, you're welcome to do so. But this is just for the folks that don't have this. Now, you may notice you don't see those those plugins here. So that is because it is installed in the WSL, the Windows Subsystem for Linux. And that is what I would recommend you to do if you have not set up your environment, you know, or having some trouble or struggling with just in general, you know, using the PowerShell and learning all these Windows commands and installing every program is kind of a pain. Then I would, recommend you to get familiar with the Linux commands. Just that is, knowing Linux, just getting familiar with it and be able to use all the common commands is going to be very important to you if you are going to work in a company. Most of the developers actually use a Mac environment, which is based off of a Unix, which is pretty much similar to Linux. And if you're using Windows as your development environment, that is fine. But now, at least Windows supports kind of provides you a similar experience as Mac, where Mac is built on top of a Unix, while Windows is totally different. But now it supports running another Linux system inside Windows. So with the WSL, you can install different kinds of Linux flavors. If you don't know what to get, my recommendation to you is Ubuntu. And there's actually a documentation on that. So Windows Subsystem Linux install. You just follow this guide. If you don't have the WSL installed, if you're doing this the first time, you would want to first run this command in a PowerShell as an administrator. And then just get straight to the WSL2. There's no point in installing an older version. So you have this executed. And then what you do is you move on to this command to enable the virtual machine platform. Now, there's a little twist if you're running Windows in Parallels, which is a virtual machine itself. But otherwise, if you're using Windows machine, you should not have any issue with it. And after this, remember to restore your machine, and they will complete the WSL install and also update to the WSL 2, version 2. Once that is done, then you want to set your WSL with the default version 2. And then you go on to install the Linux distribution of choice. Basically, I would recommend you just install Ubuntu. This is going to be available in your Microsoft Store. Just install this version 20, which is the latest stable version. And if you are successful, if you do encounter other errors, the installation of Ubuntu will show up like this in your terminal. You give a Unix username. Just give some name that's short. You will need to use this name as your login from time to time, or to escalate the permissions with a sudo. And so a name and a password after that. Now remember, this is for the user of Ubuntu system that's running inside your Windows. And then once that is installed, which may take a minute, you want to run this command, and to see if this is correct, and like you have a WSL fully installed. So let me actually, you need to run this command from the PowerShell. So if it shows up like this, Ubuntu 20.04 version 2, that means your WSL is all set, ready to go. Now, once you have that installed, you should have a Ubuntu terminal that's to access your Linux system. And that's not through the PowerShell. Now, you can get to that Ubuntu terminal. Now, if you don't have that put into your taskbar or saved somewhere you can easily access, you can invoke that from, I believe, from this PowerShell just by invoking WSL. Now you get into that Ubuntu. Basically, this is when you see something like this in a folder mounted on a C drive. Your C drive for your Windows is in a folder like this. This is your username that you set. Then this is going to be, you're actually now at the Ubuntu interface. So this is how you interact with Ubuntu. Well, Ubuntu does have a UI, but in the case of for development purposes, we're only using it in a command line fashion. So if you can check your, by running this command, SSLB, sorry, LSB underscore release dash A, and that will show you the Ubuntu version information that also kind of confirms that you're in Ubuntu. Okay, so why is it important? You need to get into this so that you can launch your VS Code. And you just type, now if you want to open a particular directory, let's say, well, there's a lot of stuff in this. I'm just gonna go into this dev folder. I created a folder under my main home folder. I call it dev. Yeah, and then I want to open this as my, well, this is gonna be where I want to put my code in. So let me see how I'm gonna do this. Use this template. Okay, so I'm gonna create a new repository. Call it Bazel demo. So this is created from that template, just like the same repo you get from the assignment. Okay, so I have a new Bazel demo repo under Professor Lee organization. So I have this just like when you accept the assignment or the lab, you get something like this. So I'm going to work on this repo. So there is a bit of a, so first thing you need to know about is to check out the source code from GitHub or any Git repository. I usually prefer SSH over HTTPS. And so there is a setup. So I'm not going to get into this, how you set this up right now, but I'm going to just give you a documentation, right? Just GitHub, SSH, setup. So if you want to set up SSH, this is what you can use just to go there and like just basically Google it and then find this link. And essentially, let me go over real quick. So essentially what you need to do is, if you don't have one already, now if you're in the Linux subsystem, WSL, for instructions, you look at Linux, because now you're in a Linux environment. And so if you just got your WSL set up, and then you just kind of follow this. Now this terminal is your Linux terminal, okay, not from your PowerShell, like a Linux terminal like this. If you're coming from PowerShell, you type in WSL, then you get into that Linux shell, or there is I believe there is a Ubuntu terminal showing up as an app. So you can click on this, I believe. This will do the same thing, okay? Oh, just you may be wondering what this is. This is the Windows Terminal app. If you're gonna work on terminal a lot, this would be the preferred, my preferred terminal app. I think is the best on Windows, and you can install this through Microsoft Store. you can just Windows Terminal. So you'll find, like, you know, in the store, and then you just install from here. And it supports multiple tabs, which is what I would like. Just like you as a browser, you have many sessions, and it will allow you to launch, you know, PowerShell or the Ubuntu terminal. So it's pretty convenient. Give this a try, usually will. And okay, so back to this. So you just kind of follow this along. You need to create a new SSH key, and then just press enter. You don't need to change the file name, and then type in a passphrase. You know, just give it a passphrase, something short that you can remember. And this is for encrypting your private key. And then once that is done, you need to do this to start the SSH agent, and then add your key, your private key, to the SSH agent. And then the last step is to add the SSH key to your GitHub account. Now, how do you add this to the GitHub account? So they just follow this link. Again, just click on Linux. So, well, this seems to be, you know, fairly complicated just to copy a key. So what you do is this. I'll just, you know, show you a, okay, so let's say you got the SSH key, you know, the key is added to SSH agent. And then you just do this. You just print out the public key like this. And then you copy this to your clipboard, right? And then you would want to paste that into your GitHub account. So the place where that is located is under, you know, your user avatar right here at the top right corner, and then click on settings. Okay. And then under the settings, you go down to, let's see, account security, no. Oh, sorry, right here. SSH and the GPG keys. Just this SSH keys are over here. So essentially, you see I have 2 keys over here. So you basically, you know, create a new one, give it a name that describes where this key is located, you know, and then paste whatever you copied from that terminal in here. So as an example, if I'm gonna copy that, but I'm not gonna save it. Okay, let's say I'm copying here. You just paste it here and then give it a title, whatever. Now, you know, what I do is this is what I do. I have my computer name, and this is you know, on my Mac, I have a Windows 10 and WSL. So you can name it something like this, just so that you know where this key is located, where you're using this SSH key. And so once you have that, you know, set up, and then you should be able to work on that clone. Let's go back. So first I need to get this code into my local disk. So I'm gonna copy this, you know, SSH URL. You can use HTTPS if you want, and then you can use your GitHub account, username and password to log in. But this is what I prefer, so that's what I'm showing you. So the first thing is I need to check out. Oops. Okay, so I need to check out. So by the way, once you have the Ubuntu installed, in Linux, Git is already there. You don't need to install Git. It's just one of the essential tools. You just Git clone. I usually like to use dep1. Well, you don't need to do this here. Just Git clone, paste that link for SSH. So, first time it's going to ask me for the passphrase. So I'm going to type in the passphrase that we set. Remember when you set up initially the SSH? So let's see. Now I have this Bazel demo folder checked out. Then open this with the VS Code. Now VS Code, has this command line tool to open up that window. So they basically type in code, and then the folder you want to open. Now, so previously I showed you that the VS Code, like you see, there's different contexts that the extensions are installed under the WSL system. So you have C++, I have another thing that's installed, and then let me also install one more thing, Bazel. Make sure this is the one from the Bazel team. It says reload required, just click on it. Okay, back to the files. Now, by the way, this readme file.md, that's a markdown file. I've uploaded, I'll share the cheat sheet for markdown format in Canvas, but you don't have to really know a lot about it to really understand this text format. And actually this, this is the source code format for markdown, but they will render. You can preview it like this. This is what you would see. Sorry, so rendered right here by GitHub, as you see like this, right? So if you're working on, a documentation. All right, so let's see what we need to do. Let's go to Bazel. Let's say we're gonna follow this tutorial to do a hello world. So the first thing is it wants me to clone the examples. So I'm gonna just do that. Now you notice, right? This time it does not ask me for my passphrase. Oh, one more thing. The setup for Git, you want to actually set up a basic configuration that's global to your Git commands. This is what I use. You can, use the same thing. And there is actually a git command to set up your name and email, or you can just create this file. For example, you can actually use a code to open this file. If you're not too familiar with the command line editor, like a Vim. So here, you can just have a file like this. Now this is a tab, by the way. You put your name, your email. This should be the email of your GitHub account. And this is a caching for your credentials. It will not ask you all the time. So you'll have this, put this inside your home directory. This tilde, the tilde is basically means is a home directory. And if I enter tilde, right, then it will be in my home directory. As you'll see, it's basically a /home/tel. This is the name we created when you install Ubuntu in the beginning. You ask for your Unix username. That's what it is. So this .git config is a Git global configuration file. So you want to have at least the minimum stuff in there. And so you can use mine as a starting point if you want. Okay. All right. So let's go back to where we checked. We have the code. Actually, this C users TL. This is actually the folder under C drive. The C here means it's a C drive. You can look at a File Explorer, C users TL. And dev, see the examples we just checked out, and Bazel demo, right? So the file system is shared with Windows from Unix, from this Ubuntu Linux system. Now, if I put files under this directory, then it will not be sort of shared with Windows. So, I mean, you can put your file either way, and that's up to you. So, but if you consider sharing with Windows, then you want to put in this mount C drive. So this is where we were. So let's go back to it. So the examples were checked out. Let's take a look, check out what's in there. Okay, it's got a CPP tutorial. I think that is probably the one we want to focus on. Okay. So let's copy that. Let's actually copy that to our own repo. Okay. So let's copy examples CPP tutorial to, let's copy this to Bazel demo. Okay. And let's take a look at the VS Code. Refresh. Now you have this folder here. All right. Now, VS Code comes with an embedded terminal. So I'm going to open that up. There's a shortcut key to open that up. It would be, oh, not this one. It would be Windows. Hold on, it would be, what is it? On the key combination for my system is going to be different than yours because I'm on Mac and have a different mapping of keys. But you can just look that up. But you can also open with, let's see from where. Sorry, there's the wrong menu. Yeah, just you can open up from there. So you see the terminal menu, new terminal. So you can do stuff like that. Okay. Now, the shell you want here is not PowerShell. You want Ubuntu. If this showed up as a PowerShell, you click on this and then select default shell. No, not this one. Well, I guess in this case, it's going to be correct because we launched VS Code from Ubuntu. But anyway, if you launch it from Windows side, and then I believe you should have a selection item here to choose Ubuntu. So anyway, so here's not a concern. So I'm just pointing this out. You may have this issue. All right, let's take a look at this tutorial. What are we doing here? It has 3 folders. Actually, each one of them is called a workspace. It's a Bazel workspace is identified with a file called workspace. So workspace is kind of the root folder of a project. In this particular setup as a tutorial, it has 3 projects. So what it's trying to say is, okay, let's take a look at the build file in stage 1 main. Now, the way Bazel works is that every folder is considered a package. And in that package, it's called a Bazel package if you have a build file under that folder. And this may be, if you have a multiple level of folders here, then you have this build file at the innermost folder. And then that whole long path, is considered a package in Bazel. So let's take a look at this file. Okay, so here the VS Code is telling me a buildifier not found, linting and formatting of Bazel files will not be available. Well, that sounds good. We want to have linting and formatting for this Bazel files. So let's see if we can, download that. Now, if you are installing on Windows, and you probably can download and install this, but then let's see what kind of instructions it provides for setting up on Linux. Buildifier. Okay, it's over here. Okay, it says it needs to use Go to install it. So I'm going to try something. Actually, I'm not sure if it's going to work. So Let's see, Buildifier. Not sure what platform this is built for. Do we have to install Go? You know what? So I'm gonna skip that Buildifier for now. If I figured out an easy way to do this. At this point, I don't want to install Go and use a Go to install Buildifier. And so that's not the point of this tutorial. So let's just skip that for now. I may send them some instructions later on if I find out a better way to do this. Okay. So that's ignore that suggestion for now. But it does help you writing these Bazel files. Now this format you see here is written in a language called a Starlock. The Starlock is actually just a kind of a subset of a Python. If you are familiar with the Python, and essentially this is the same Python syntax, and it works very much like Python. Okay, so it's like a function call here. Load is, well, in Bazel context, it's like importing some external, well, importing a library that may or may not be external, by the way. So if you see this at with a name here, at rules_cc, that means this is a workspace that's external to your local workspace. So this is actually from, well, the Bazel installation. Bazel comes with it. So this is built-in stuff from Bazel. So this is some files inside the Bazel installation. You're reaching out to that particular workspace, and then after the double slash, this is kind of the root path from that workspace. And then before you see the colon here, and could be a path, A/B/C, and that is the path to a build file. Is a package. Actually, this is the package name. And so as I was explaining, this main would be a package in our own local workspace. And then this is a file under that package. This is an extension of Bazel. Is written, well, the BZL file that's a Starlock source file. So it's trying to load up that file and importing this particular function from that file. That's what it means. And so now you get to use the cc_ binary. This is to build a C++ executable. And it will give it a name and then the source files. The source files could be header files or, the C++ source files as well. So this here is very simple. You have a single C++ source file here, right? So the details of this file don't really matter at this point. We're just building a hollow world. Now, let's see if we can run this. It says the insiders version is available. Well, we don't want the insiders version, so I would recommend you just install the stable version, not some experimental alpha version that's going to cause your system unstable, and you don't want to waste time on that kind of stuff. So I usually just turn that kind of stuff off, and I'm just going to say don't show again. All right. Okay, so let's right here. Let's go to, you have to get into the folder of your workspace first. So let's go to the stage 1. And then we're gonna run Bazel. Now, I did not, now installing Bazel from the Linux system, and let me actually, that's the first thing you wanna do is to install it. Let's open up a new hold on, I'm gonna see the toolbar. Okay. installing, okay, overview. Okay, we're gonna go say we want to install on Ubuntu Linux, okay? So you go to that, you just navigate to it, and it's gonna show you how to install it. So this apt is the package installer for Ubuntu that comes with the operating system. Just follow this, right? Run this command one at a time. I've already done this before, so I'm not going to repeat this. Just run this inside. You can run this inside here as well. For example, right? So for example, I install this. Well, it doesn't hurt. I install it one more time to show you guys. So you notice it's sudo. Sudo means to get a super user permission. And that's, like when you run a PowerShell in an administrator mode in Windows, that's kind of what it means here. And it's going to ask you for your password. This is the Unix password that you set up initially when you install the Unix Ubuntu from the Windows Store. So I'm just type in the password. And then here it says it's already installed, so nothing to do here. That's fine. So you just go through this. Each line is a command. They just run that. Well, this is a one line, by the way. This is not two lines. It's just wrapped into second line, okay? This is gonna specify, what this is doing is to get the, where to fetch Bazel, like the repository, where to get Bazel, put that into the Ubuntu system so that it knows where to fetch it. And then you go and install with this command. Now, so usually with apt install, you usually want to update first. So this may take a minute or two. And then you just run this. This is like the two commands connected together, and you run this and then this. So, and once you have that, and this should just be installed. So if you just to check if your Bazel is there, you run this Bazel dash version, and it will give you the latest version, which right now is the 3.4.1. Now there's different ways of sort of a launching Bazel, by the way. So I'm not gonna go into that alternative at this point, and that tool is called Baselisk. If you are interested, that helps you pin down a version for your workspace. Now for the purpose of this course is probably not that, significant, but if you're working on a project with a team, and this is probably something you want to look into, this is essentially manage different versions of Bazel. You can specify a particular, pin down a version of a Bazel for a particular workspace. Doesn't matter what you have installed locally. And this workspace is saying, okay, I want to use this particular version. So that's what it will help you to do, Baselisk. All right. So let's say you have Bazel now. Okay, before, I don't even need to actually understand what targets you have in the build file, right? What the paths are. I can just run this, make sure this works always. So Bazel, build and / dot. That means build everything. I don't even need to know what the name is now, although, this is defined right here, right? It's that particular target, and this is called a rule. And this is, a rule is called a target. And so this is the name of that rule, and this name, and by the way, this particular identifier here is actually called it's a label. And you should read up more about what labels are, but for the time being, just remember this couple of basic commands. And now it says build completed successfully. Okay, good. Now, well, let's make it a fail. Let's say I have a typo here. This file doesn't even exist. Let's see how it goes. oh, it'll tell me, right? So see, it's going to tell me this. It says missing input file. Now this is a label. This points to this file // Now, if you see the similarity with this guy here, if it's omitting the at with a name, the at with a name is actually identifies a workspace. This is external workspace. If that's omitted, that means it's just your local workspace, your current workspace. And then the main is the path of the package. The package is a main that folder because it has a build file in it. It's a package, and then this is the file under that package. Well, because I had a typo here, this does not work. If it says it's missing, well, of course it's not going to find it. Let's say we're going to fix it and run this again. So it passed. Okay. So then you move on to, this is kind of introduce you the concept. So to build a executable application, this is sort of is a bare minimal, right? The workspace you see here right now is empty. Now this, in a sophisticated project, in a real project, this may not be empty. What you put in here is called the workspace rules or repository rules. This is where you load up your external dependencies. And if you need some library, for example, Google test externally, and that comes from somewhere else, and then you put it over here to load up the external dependencies so you can use it in your project. Now, for the purpose of this lab, this is later on when we get to work on other assignments and labs. And gradually, we may end up using a little bit more feature, and things will make it easy. Okay, so let's look at stage 2. Now, stage 2 is a little more complex, right? So as you see, we have 3 files here. You still have a hello world file, which includes a header, hello greet, right? Hello greet seems like it's a module that we separated out from the original application. And so this defines one function, and this function is implemented in this file. Well, which is very simple, hello plus a name, right? Now, how do we build this? So again, they're all in this one folder. So this is one package. And so before we look at the one before, now this is almost like the same as stage 1. We need to create a binary, hello world. Oh, one more thing I did not do is go back to stage 1. And we need to run the file. Okay, so it was built, but is it going to be successful, right? So we don't know. So we're going to just run. We need to run that hello world app that was built, the executable. Okay, so that did not pass. Why is that? Let's go back there. Well, that is because, by the way, this is a label. It's not going to find hello world at the root of the workspace. It is from the package main and then colon hello world, right? So you see now in this case, I can type in main because it's relative to the root, or you have the double slash here that prints out hello world. Now it's pretty verbose. It has a bunch of logging messages to show me how this Bazel ran, but the actual Well, the actual output from the app is probably the last two lines, right? So this is how you run it. Now you say, well, where exactly is this hello world? Well, it's a good question. It built the files are somewhere, and then where are they? Well, there you go. You see those folders? I did not refresh. The hello world is actually under this bin folder. And under that, you have the package path, right? So main, and then you have hello world underneath. So essentially, you could also just invoke that directly. So I'm going to just invoke it from that bin folder, okay? You're just running that app alone directly without invoking Bazel. And it's a bunch of output from Bazel. The actual app just outputs hello world and then a timestamp, right? Now, it's not always the case that this, by the way, these are symlinks. You see this arrow here. They point to somewhere else. As you see, the full path is a symbolic link. Well, actually, anyway, so it may not be in your local directory. So this is, so in the future, maybe we'll see a case where we have a little customization with the workspace or the for Bazel to not put all your folders in here. And that's definitely doable. Then those folders will not be here, but then you can always query. There would be some kind of a private folder somewhere on the system. You can actually find out where they are because right now we kind of already see where they are. You can just by running, Bazel info output base. Yeah, this output base shows you where that file, that the actual folder is. Well, actually, this symlink points to here. You could, customize Bazel not to even, have these things here. But anyway, so the actual place where this is located is actually, right here. Let's take a look what's inside. All right. So anyway, those are some of the things that, again, it does not make a whole lot of sense, but I believe the exact root. Bazel out. Oh, not Bazel out, sorry. That is actually under main. All right. External. Now, Bazel info, actually this output base is pointing to actually this folder. Yeah, exactly, this is what this is. And then what about the bin? Well, where's the bin folder actually located? Let's see if we can find out. We look at a command line documentation. Execution root. output path. Execution root. Let's see what is under execution root. Okay. Well, it's somewhere in one of those folders. Anyway, let's skip over this for now. All right, let's move on to the next thing. Let's go to the stage 2. Okay, stage 2. Okay, the point of stage 2 is to show that now this hello world file has a dependency on another module, which is in Bazel, it's called a library. So we're building this hello greet module, and it has this header file. And when you put this in the headers attribute, it means this is the public interface to that library. Now, if there's something that doesn't have an interface, then you just put this into the sources, so they will not be exposed. But anyway, in this case, this is the library. We want to have this interface. This will be used by Hello World. So this is the source, the source file, and then we'll give it a name, hello greet. And then the binary uses that library because that include the header of greet. If you look at this, this is in your code. This is how you establish that dependency. So Bazel needs to know that, and so you specify that as a dependency. Now this column here to indicates that is a label, and so it points to this library, this name here. Now remember that whole full syntax of a // if you're starting from, well, we'll test this out in a short bit. So let's first build this first to see if this works. And well, as you might notice, it loads up a bunch of different packages, does a bunch of things. Now we have not configured sort of a caching for, in a larger project, you probably want to do that. But anyway, so not to complicate things, this is just a simple user scenario. Let's say we're not too concerned with the speed. And then let's run the hello world. See if this still works. Now this is in stage 2, so it still prints out hello world, that's fine. Now, does this hello world actually take an argument? It does. Okay, so let's see. John. Hello, John, right? So you can basically look like this. These are the arguments you provide to the app. Okay, so back to this. Now, I was saying, this is because it's relative, is right here in the same package. So you can just refer to that, target name without any path. Now you could say, I want to just go from the root of the workspace, and this should work the same way. Let's see. Right, that works. Well, what if I say, well, let's make it a different folder. I want to specify my workspace. Now in this case, you don't even have a name here because it's anonymous, and also it's the current workspace. I believe this should also work the same way. See that? So, but you can just omit all these parts. And by the way, you don't even need to have that colon. it should still work. Having the colon here just to indicate this is a label. Right? It's just kind of a conventional thing. You don't have to use that. Okay. So that's basically stage 2 of what this is trying to show. Let's go to stage 3. Okay, stage 3, now we have more than one package. So you see this build file here, there's a lib package. We separated a module out called hello time. And then we have a main package where the hello world application along with another module also in the same main package. Now we're familiar with this. This was from stage 2 essentially, right? Now there's a tiny little difference because this hello world binary also depends on another library, and that is in the package of a lib. And now previously I showed you can use / main because that was in the same package. You don't have to specify those. It's a relative path essentially. And now this lib is not in the same package, it's a different package. So that's why you need to specify the full label so that Bazel knows where to find it. So hello time, and then in this, build file for that package, you have that is just the same as, now there's something interesting here, visibility. This is telling you that I want to expose this package, make it visible to the main package on a package level. Only the main package essentially can access it. If you have a different package, it is not made available to it. This is trying to encapsulate, say this is an internal library, I'm not going to use it elsewhere. So that's kind of what that indicates. So first, I don't even need to know how many packages, how many targets are here that I want to build. It doesn't really matter. I'm going to build the whole thing. Bazel build. Okay, so it built. Now, by the way, if you run this a second time, it's not going to take any time because, it's already built everything. Okay, let's see if we can run this thing, right? Before I even get to understand the different parts of it, let's just say I'm going to run. Now, of course, I need to know where the app it's specified. So it's in the main package. At least I need to know that name. Now, by the way, you can query the list of the targets. What are the the rules that you can use. But anyway, so this will run. Hello world. You might have noticed that I did not specify // That's because I'm in the root of the project. Now, if you use // that will work the same way. Okay. So that works. And yeah, so if you look, there's really nothing, new here except the visibility attribute. And then this hello world. Now, this hello world build file depends on one more package. Essentially, you could also, let's say, move this grid into another module, another package, perhaps. Then you can still make that work. For example, what if I put that, time under time. And the what if we'll create another one called greet. Yeah, let's move, let's say these under greet. Oh, by the way, as far as this tutorial, I mean, we went through the whole thing pretty much. This is just something extra I thought might be useful, how you normally would organize your code. So in this case, let's say I'm gonna add, for that package, I need to also have a build file. Essentially is the same as this guy. Call this hello greet, right? And then here, so the path to hello time is going to be lib time. And then my hello greet is no longer here. And hello greet is available under lib greet. Okay. Let's see if this works. Did not work. It says, oh, main hello greet, no such file. Okay. I forgot to change something. And that is under the greet build. Oh, that include file is wrong. So is the the thing about the include, the way with the Bazel, you actually need to include, well, you actually need to use from the path relative to the workspace. Now let's fix this one. I think it's going to complain about the other one as well. Main hello world. Lib hello time. See, this is no such file or directory, because now the folder structure has changed a little bit. Let's fix that. Okay, we need to fix this. Lib greet. All right, that worked. Let's run. Hello world. Okay, that works. So what we just did, we basically moved that hello greet into its own package. And so this is like now in the lib folder, I have two packages essentially. In Bazel, a package is defined where you have actually a build file. This is the package. This is a package. So I have two packages. And then this main is another package. And this is my application that depends on two modules under the lib folder. Okay. So this perhaps is more of a common organization for your code. At least the relatively simpler projects, you may consider doing something like this. So now you've got all your files ready in your workspace. We have not pushed them to GitHub yet. So that is the last thing to do. So let's actually do that. So if you look at the GitHub repository, where's that located? Okay, let's go to github.com. This is the repo. So you see, we didn't have anything here. Now we need to check in the code. So you would go, well, actually, it doesn't really matter what directory you're in. Now, first thing you want to do, usually what I do, git status first, right? So git status says, well, there's untracked files, and is on branch master, is up to date with the origin master that's saying, well, this, except those files that are not tracked, or the files that are actually tracked, they're in sync. Well, let's actually go up to the root of our project. Let's do another git status. Now this says, well, this CPP tutorial folder is new and there's not being tracked. Now the other files that are tracked, for example, that README file is the same as was in repo. Now if I make a change here, blah, save it, and then it's gonna actually show me to say, well, that was modified, right? So it will detect the differences with the remote repo. So I'm not gonna change that file. I don't need to. And then, this is what I want to check in. So first thing you want to do, you git add. Well, the git add, if you have a bunch of things that are all changed here, that's all the things that you want to check in. Like in this case, it's just one thing. You have a bunch of files, they'll show up, and you can, you want to add everything, just git add -a. And there's another, well, I'm just going to show you part of because the git commands, there are plenty. There's a lot of shortcuts to do things and efficient, but so I'm not going to introduce you to all the commands that are there. So if you just do git add -a and then do a git status again, now you see all these files there's under this CPP tutorial are now changes to be committed. It says they're all new files, not modified from the existing file. They're all new files that did not exist in the remote repo before. Okay, so now I have this added to my local cache. This is actually right now, it's just in my local git cache. The git is not aware of those files. Okay, so this is what you see here. Now we need to create a commit. Now commit is a unit of change in Git. If you look at the GitHub website, you'll see everything is about a commit. Now you see this as a one commit is the very first commit that was copied over from the template. And if I want to see what's in that commit, I can click on this and it will actually show me what was the change. Well, I had a new file, git ignore. I had another new file, readme.md, and it shows me very nicely, okay? But this is kind of the units of change in Git. So everything is a commit. So if you want to push some change to it, it could be one commit, could be many commits in one push. So for every commit, you need to provide a meaningful message. What was this change about? Let's say, I'm add CPP tutorial, from Bazel tutorial. Okay, well, whatever you want to write. This is meant to communicate what this commit is so that other people, if you work with the team, they know what this change was about. You provide a message. Now it shows, give me the output to say, well, now I have this message and these are the files changed. It even shows how many lines were inserted, okay? So now I have the commit locally. It's in my local Git repository. Git is good, all good locally. It will not show you, if you do a Git status again, it will, not show those files are, not changed, or knows you have some new files or something that's not tracked now. So the Git is satisfied locally, but it says, well, the branch is ahead of the region master. That's the remote repository in GitHub by one commit. Remember, that's a new commit. It says use git push to publish your local commits. That's what we're going to do next. Git push. Now, when you do the git push, we need to, first time for a change like this, it will ask you a passphrase. And then this is the password you set up when you initially go through. Remember that SSH key? One of the steps where you need to put a passphrase for the private key that it uses to encrypt. So this is what this is about. Put in that. Okay, now this shows me my local master is pushed to the remote master, and they're now in sync. Okay, so if you look at this, GitHub, you refresh it. Now you should see that new folder. And that's from a different commit. Now I have 2 commits total. So that new commit with that message right here, this is right here. Now, if I look at this change, well, you can click on this as well. And now you see, it shows me all the files that I added. Okay. And then if you click on this folder, this is the 3 stages, all these files, right? The build files. Now, interesting fact, if you look at a GitHub, it analyzes your code. It says 63% is C++, and 34% is Starlock. So it does recognize Starlock language now. And then it's 2.9% of C, probably from the header files. So that's pretty much that. And I wonder if we do another push, but right now I have no change. It looks like we have not set up properly the, this SSH key actually is not set up properly. I thought it was done. Actually, I did not follow through on the whole thing, I guess. So let's actually look at that. So what you search, I believe I missed one thing, GitHub SSH setup. And just go to that tutorial. What I'm missing here is to add this key to the SSH agent. I believe that's what's missing. I do have the SSH key. Let's run this. See if the agent starts. Well, actually, we'll see if this is actually in this SSH agent or not. Okay, it has no identities, you see. What's missing is that particular SSH key needs to be added to SSH agent. And by using this SSH add command with the path to the file, was just, this is the default file name. This is what I have locally too. You didn't really use a custom name, you could. And then, the password to that. Okay, so that identity is added. So now I don't have to put in my password every time. See that? Now this just works. Okay. To show you this is not specifically this particular repo, if I check out another repo, it will not ask me that again. So let's say I want to check out this build tools repo. Copy. Git clone. Now to speed up the checkout, I usually use depth 1. I don't want all the history of the previous check-ins. I just want the current code. So this is what I do. I check out this repo. As you see, this time it does not ask me credentials. Right? And then you have this build tools here, which I do not need. I'm gonna remove it. I'm also gonna remove the examples. Right? So that concludes this Bazel tutorial, Bazel demonstration. Thank you.